Good afternoon, children. Welcome to 8th standard online physical science class. This is standard 8 for chemistry lesson 6 continuation. Okay. Oxides and their nature. We are going to discuss about the oxides and their nature. Oxides are prepared by the direct combination of elements with oxygen at higher temperatures and decomposition of some compounds like hydroxides, carbonates, sulfates and nitrates. So oxides, how oxides are prepared? There are two ways. One is by the direct combination of an element with oxygen at higher temperature. So here are the example. When hydrogen combined with oxygen, it forms water, and carbon combines with oxygen, carbon dioxide, sulfur plus oxygen, sulfur dioxide. All these are oxides. Okay, similarly with the metals like magnesium and calcium also, MgO, CaO, magnesium oxide, calcium oxides are formed. This is the example for direct combination with the oxygen. Do you understand? Yes. What is the next type of preparation? Decomposition of some compounds like hydroxides, carbonates, sulfates and nitrates. So look at these reactions. Zinc plus zinc hydroxide on heated, it forms zinc oxide. Similarly, cuprous hydroxide is heated, it forms copper oxide. Okay, copper 2 oxide is formed. Then with carbonate, this is about hydroxides. OH means hydroxides. Carbonates, CO3 are the carbonate radicals. Okay, CO3 are the carbonate radicals. So calcium carbonate, when it is heated, calcium oxide is formed. Zinc carbonate, zinc carbonate is heated, zinc oxide will be formed. Lead carbonate is heated, lead oxide will be formed. Copper carbonate is heated, copper oxide will be formed. So these are what to say, they are decomposed. Okay, these compounds are, that is the carbonates are decomposed to form the oxides. Here in this case the hydroxides are decomposed to form the oxides. Is it clear? What about the next one? Sulfates. Some sulfates also, when they decompose, they form oxides. For example, ferrous sulfate, when it is heated, it forms ferric oxide. Okay, ferrous sulfate, when it is heated, it forms ferrous oxide. And copper sulfate is heated, copper oxide is formed. Okay, do you understand? So the sulfates also decompose to give this oxide. Similarly, nitrates also decompose to form oxide. Calcium nitrate on heating gives calcium oxide. Lead nitrate on heating gives lead oxide. In all these cases, there is the nitrates, sulfates, carbonates and hydroxides, they decompose to form the corresponding oxides. Do you understood this, children? See, here is the experiment of formation of lead nitrate. Lead nitrate, when it is heated, it gives a brown fumes. Fume means smoke. Okay, of nitrogen dioxide. This brown fumes are the indication of formation of nitrogen dioxide. And nitrogen dioxide, and what is formed along with this lead nitrate? Nitrogen dioxide and lead oxide is formed. Lead oxide and nitrogen dioxide is formed. This brown fumes indicates the formation of that nitrogen dioxide. Okay, now how the oxides are classified? Oxides are classified into neutral, acidic, basic and amphoteric oxides. Okay, neutral, acidic, basic and amphoteric oxides. Examples of neutral oxides are, they are neither acidic nor basic. Water, carbon monoxide, nitrous oxide, nitric oxide, all these are examples for neutral acids. Neutral oxide. Now acidic oxides. Acidic oxides are the oxides of non-metals are acidic in nature. They dissolve in water to form acids. Okay, they dissolve in water to form acid, so they are anhydrates of acid. Anhydrates of acid. Anhydrate means what? Anhydrate is the one from a compound that is obtained by removing the element of water from an acid is called anhydrate of acid. Okay, when you remove the water from the acid, that is what is obtained. That product is called anhydrate of the acid. And here, look at here, H2CO3, carbonic acid. It's the anhydrate of acid is CO2, carbon dioxide. And when you remove CO2, it will be water, isn't it, from H2O. From H2O, when you remove water, minus H2O is removed. What is left out? CO will be there. So CO will be the anhydrate of H2O. Okay, H2CO3, carbonic acid. Okay, then hydrogen sulfide, sulfur dioxide is the anhydrate. Hydrogen sulfate, sulfur trioxide is the anhydrate. HNO3, N2O5 is the anhydrate. So these are the oxides. All these are oxides. This carbon dioxide, SO2, SO3, N2O5, all these are anhydrides of the corresponding acids. Do you understood what is an anhydrate? Yes, so they are acidic. All these acids are, all these oxides are acidic in nature. All these oxides are acidic in nature. Do you understood, children? Yes. The oxides of metals are generally basic and react with the acids to form salt and water. Okay, normally non-metals are acidic in nature. The oxides of non-metals are acidic in nature, whereas the oxides of metals are basic in nature. And they react with acids to form salt and water. Okay, that is neutralization reaction. For example, N2O. Okay, N2O, when it reacts with the acid H2SO4 sulfuric acid, it forms what? Sodium sulfate, Na2SO4 plus water. Okay, this is a neutralization reaction. So these metal oxides, that is basic oxides, are always metal in nature. Metal oxides are always basic in nature. We can say in that way. Okay, do you understood this? And finally, amphoteric oxides. Amphoteric oxides are the oxides those behave as a base in the presence of acids and as an acid in the presence of bases. Okay, this amphoteric oxides, they behave like a acid in the presence of base and base in the presence of acid. See, you might have studied about amphibians in your biology. That is the living beings which can live both on land and water, isn't it? So like that they behave both as acid and base. Okay, yeah, that is called amphoteric oxides. Examples of amphoteric oxides are this zinc oxide. When reacts with the sulfuric acid, it forms zinc sulfate and water. Okay, it forms zinc sulfate and water. Similarly, lead oxide, when reacts with the nitric acid, it forms lead nitrate and water. And base and salt, base and acid reacts to salt and water to give, for example, base is sodium hydroxide plus zinc oxide. It forms sodium zincate, Na2ZnO2 is sodium zincate, and water will be formed. And sodium hydroxide and lead oxide, it forms what to say, so sodium plumbite plus water. Okay, see, when you look at these cases here, the oxide behaves as a base. Okay, in the first case the oxide behaves as a base, whereas in the second case the oxide behaves as a water, acid. Okay, so in the presence of acid they behaves as a base, and in the presence of base they behave as an acid. So such oxides, here the same zinc oxide behaves as base in the presence of acid. The same zinc oxide behaves as acid in the presence of base. Do you understand? So these type of oxides are called to be amphoteric oxides. Do you understood what are amphoteric oxides, children? Hope you have understood what are all amphoteric oxides. The some examples of amphoteric oxides are aluminum aluminum trioxide, that is Al2O3, aluminum oxide, zinc oxide, lead oxide. These are all examples for amphoteric oxide. Aluminum oxide, zinc oxide, and lead oxide are examples for amphoteric oxides. Okay children, so ZnO, PbO and Al2O3, these are examples for amphoteric oxides. Hope you have understood the class very well and enjoyed it also. So complete the assignment and report in the group without fail children. Also learn well for your upcoming midterm exam. Thank you children. Meet you again.